Hi, and welcome back to the MakerPunch channel. The idea of MakerPunch is to make CNC cutting of sheet metal accessible. In this video, we are going to take a look at a really simple CAM pipeline for it. This was actually one of the first pieces of the whole MakerPunch project, just to see what it can do. Just to give you an overview of the whole process, we use a CAD program to create a model of the object we want to produce. A CAM program takes the model and produces G-code, which contains instructions like go there, punch a hole, go there, punch a hole, and so on. The actual MakerPunch is a machine that reads the G-code, executes it, and as an output you get a CNC cut piece of sheet metal, ready for bending. So, before diving into the CAM, let's use CAD to quickly model a very simple bracket, just 3 screw holes and a straight angle. Here. In the end, we go to the flat pattern mode to get the flattened out model of the bracket and export it into a ezdxf file. And we're done. The ezdxf contains the shape we would like to punch out of metal. Let's go build our custom CAM. We are going to be working in JupyterLab, my go-to environment for hacking. For this video, I made the JupyterLab notebook a little more self-contained than usual. Normally some of the code would be in separate Python modules. Let's start with a license. The plan is to make all the MakerPunch software free and open source. AGBL 3.0 is the license, at least for the time being. We start by importing some packages. We use ezdxf for reading the DXF we just made. Let's take a look at what's in the file. A bunch of objects of various types. Luckily, ezdxf now allows converting everything to line segments. For that, we write this backend that just stores all the line segments. Let's run it and take a look at what comes out. There's our bracket. The plotting software matplotlib automatically colors each separate line so we see that everything is in small pieces. And it has also included the bend lines. We really don't want to punch along those lines, so let's remove them. I already included the code here and just commented it out, and there. This is what we want to punch. But for that to happen, we have to go from line segments to a more holistic picture of the object we are punching. For example, you really want to punch outside the object boundaries, not inside. So the first step is to combine those line segments into polygons. This code just looks for line segments with the same endpoints and combines them into a polyline. And let's plot the result. And nice, the coloring has changed. Now each separate contour is one polyline. For the next step, I'm going to borrow some functionality from another project of mine, plycutter, which is a totally different kind of CAM for making these funny laser-cut plywood objects that have been laying out around in the videos. We'll turn each of these outlines into a polygon, and then run this special code that basically XORs, exclusive ORs, them together, and voila! Now the computer understands what the object we are trying to build is, and what are the holes. Next, a couple of classes that represent the punch shape and the positioning of a single hole by a particular punch. This is maybe a bit too complex for what we are doing right now, but it just felt better to write it this way, planning for the next expansion steps and, for example, automated testing. The punch is a 3 by 2 mm oval shape that has a 1 mm straight edge along each side. This allows us to cut theoretically straight edges, unlike a round punch would, but it requires us to rotate the punch around. The first simplest version of the CAM will just place holes like this at 1 mm intervals along a curve. Here we dilate the object by 1 mm to place the center line of the punch just the right distance outside the object. And here you see the punch holes. Let's plot the original object in here so you can see how the holes fit right around it. Let's make that line a little thicker. So, I would say this is a success, and punching these holes would cut out the bracket we modeled, ready for bending. Now that we have the holes, we can generate G-code really easily by just printing them out like this. Another thing that we can do with the holes is we can plot them in a different way. This is actually how I made the animation in a previous video. This is, of course, still a really simple and basic version, but I think this version is almost enough to make some fun and interesting project with the MakerPunch before it becomes the limiting factor. But we'll figure that out later. Anyway, here's all I have for now, and thanks for watching.